Hello guys, this is prime concept. Now I'll be solving this problem which I solved in my previous video. I'll be solving it again using another method, which is method 2. So like I said earlier, when I finish, you choose which method you understand best and follow up on that method. So I'll be using the concept of unit vectors to solve this. But before I do that, let me quickly draw the solution diagram. Now we have two charges, Q1 and Q2, are located at the positions R1 0.3 meters J. J simply means y-axis. So this is a positive value. So it means positive y-axis. And 0.4 meters I. This is positive. So it means positive x-axis. I means x-axis, right? Now the question says the force exerted on Q2 by Q1. So the person exerting the force is Q1. The one receiving the force is Q2. Remember, the one that exerts the force is your source. The one that receives the force is your what? Test. So they want us to find the force that Q1 exerts on Q2, right? Yes, on Q2. We want to find the y and x components. So let me draw the solution diagram. Now, if this is my origin, I have that Q1 is located at 0.3 meters along the y-axis. So this is going to be my 0.3 meters pointing up. From origin you go up. So this is my Q1 positive, right? And then Q2 is located along 0.4 meters positive x-axis. So this is it. This is it. 0.4 meters. So this is where I have my Q2, right? Then I have to connect them because Coulomb's force acts along the line joining the charges. So I have to always join those charges. So I will join, right? Now, since if you check, Q2 is positive, Q1 is also positive. So what it means is that the force, the kind of force you would have here is going to be a repulsive force. And repulsive force will point in what direction? It will point away from your source. This is our source, away from the source. So it's going to point like this, out of that source. Now, what I want to find is R12. That is this distance is what I want to find, R12. So for me to find R12, I'm going to use the concept of vectors. The concept of vectors. So now, since you are here, this is where you are because it is Q1 that is exerting the force on Q2. So this is where you are. If you move like this, you have R12, which is this. That is the length, right? Equal to. Now, you come down like this. Whenever you move, because it's either you move from, if you want to get to Q2, you can either follow this direction, which is your R12, or you follow this direction, you come here, and then you go here, right? Now, when you are taking this direction, take note that you are moving opposite to the normal direction. So it's going to be negative. You are moving opposite now. So it's going to be negative 0.3. Remember, this is your y. So I will use J. When you get here, you now move like this. You're moving in the same direction as the arrow. So it's still positive. Positive what now? 0.4 I. So it is customary to write I before J. So what I'm going to do, I'm going to rewrite this as R12 equals what now? 0.4 I minus 0.3 J. So this is a better way of writing. So I've gotten my R12. The next thing I want to do is to find the magnitude of R12, right? Which is this length. So R12, the magnitude is this 0.4 square minus 0.3 square. So if you punch this with your calculator, you get 0.5 meters. So I'm going to rub this so I can have space. Now, the next thing I want to find is my unit vector. My unit vector R1. So I want to find the unit vector. Remember I told you the formula for unit vector is R12 divided by the magnitude of R12. So this is how we denote magnitude. The magnitude of R12. So what is our R12? R12 is 0.4 I minus 0.3 J. divided by our magnitude. What is our magnitude? 0.5. So if I solve this, I'm going to get 0.4 divided by 0.5. This divided by this would give me 0.8i. 0.3 divided by 0.5 will give me 0.6j. So this is my unit vector. And the next thing I want to get is to get my force that Q1 would exert on Q2. So I would call it F12, which is going to be K Q1 Q2 by R12, right? Square. So what do I have here? I have K as 9 times 10 to the power 9. I have Q1 as 5 times 10 to the power minus 6. Q2 as 20 times 10 to the power minus 6 divided by R12. What is our R12? 0.5. As the magnitude, you can see it, 0.5 squared. So if I punch this, I would get, okay, it's going to give me 3.6 Newton. So this is my F12, 3.6. But this is not what we're looking for, I'm sure you know. So we want to get the Y and X components of this force. So since I'm done here, I'm going to rub this. So take note of this solution diagram, it's very important. So I want to solve now, because according to Coulomb, the vector form of Coulomb is F12, the net force. Our net force now is going to be F12 times R12, our unit vector. So what is my F12? My F12 is 3.6. What is my R12 unit vector? Is what now? 0.8i minus 0.6j. So this is what I have. So if I expand this, I will get 3.6 times 0.8. So this is going to give me 2.88i. This 3.6 times this. So this is going to give me 2.16G. So I told you that anything you have that is associated with I is your X component. Anything associated with J is your what? Y component. So if I'm to bring these things out, I would have that Fy is going to be what? This is your Y, is going to be minus 2.16 Newton. And then my Fx is going to be what? 2.88 Newton. So these are my Y and X components of the force. I believe this concept is very clear. So what I want you to do is to compare the first method in my previous video, which you would see down below this video, and then this method, compare and check which one is easier for you, and put your comment in the section. Let me know which method I should continue with. I believe this is clear. Thanks for watching. Do subscribe to my channel, like and share with your friends so that they can also benefit. Remember, this is prime concept. I'll be solving more videos on this. Thank you.